So what I did, let's see, what I did here is added to this little sketch. And for fun, what I decided to do was replicate what I did with the circle animating from the top of the screen down to the bottom of the screen. And I added a square that moves from the left side of the screen to the right side of the screen. And I did something, very, very similar to my two user-defined functions, draw circle and move circle. I have very imaginatively named draw square and move square. So up the top of the program, I declared another variable, let square x equal to 0. And then down below, I've got a couple of different functions. They're very, very similar to the animating circle functions. Here's the function to draw the square, and this creates a fill color, which is blue, no stroke, and then here I call the square function in P5.js and provide basically the x-coordinate, which is square x, again, equal to 0 initially, and then place that on the y-axis at 100 with a size of 100. Basically, that's the height and width combined. That's the way in which square takes its arguments, basically. And then I have the other function move square, which is just like the circle function. The only difference being that instead of incrementing the circle to move down to the bottom of the canvas, instead I have the square basically incrementing and moving from one side of the canvas, the left side of the canvas, all the way to the other side, and when the canvas hits the other side, it resets. So, this is really great because you can imagine my function draw is actually rather neat and compact, and all of the other functions that animate both the circle and the square are down over here below. And I can change those functions, for example, if I wanted to. So, then what I'm going to ask myself is, this idea of modularity, I've definitely been able to make my code modular. The question becomes, how do I go ahead and also make it reusable? Let's say I wanted to actually have multiple circles and squares in the sketch at once. Okay. So what I'm going to do is actually create parameters in my functions. And when I go ahead and create these parameters in the function, then I can go ahead and pass arguments to that function. So let's go ahead and take a look at function draw circle. That is this function right here. Okay. What if I wanted to be able to do things like, for example, change the position of where the circle actually starts animating? In this piece of code with circle 100, the circle is always, it's hard-coded, it's always going to start at 100, right? Circle Y is changing, and that's where the circle is on the y-axis of the sketch, and then the sort of the diameter basically of circle is 100, and it always stays the same. So what if I were to go ahead and introduce parameters to this function? So 100 could actually be x, for example. And the diameter, I can give it a variable. I can assign it a variable, diam circle. I'd probably come up with the worst variable names, maybe. And then what I'm going to do is I'm going to actually go ahead and put those variables into this function right here. So what I have here is function draw circle with the parameters x and diam circle. And then you'll notice that I'm going to use those parameters x and diam circle to go ahead and determine where the circle appears in on the canvas in the x-coordinate, as well as the actual diameter of the circle itself. So if I go ahead and play start, you'll notice the circle disappears, and that's because I'm calling draw circle up here, but I'm not passing any arguments to it. So the function, when you're creating the function, these are called parameters when you're defining the function. When you are calling the function, you basically have arguments. They become arguments. And so what if I want the draw circle to not appear at 100 on the x-axis, but I wanted to define this argument instead as 200. And I want the diameter of the circle, diam circle, not to be 100 as it was previously hard-coded, but I want it to instead be at, I don't know, 50. And then I go ahead and run. And so you'll see then the position of the circle moved, and as well as the diameter of the circle actually changed because I passed different arguments. These right here, 250. 200 stands for x, 50 stands for diam circle, and when circle goes ahead and is called within this function, x becomes 200 and diam circle becomes 50. And so, you know, I don't actually have to declare these variables as lets. The fact that I introduce them as parameters within the function actually declares them for me. So now what I can do is I could actually call multiple different draw circles. And let's say I wanted to have 2 circles and I want them to animate. Well, then what I could go ahead and do is, you know, switch this over to 10. And, oh goodness, what happens if I put this to 100? I actually don't know if this is going to look terrible. Oh, there you see. Now what we have are 2 circles, and they have different diameters. Because the arguments that I pass the function are different. Then if I wanted to do this as well for drawing the square, I could do the same thing. I could say that the parameters that I wanted to find for the drawing a square would be different as well. So here I have square x as the location, the variable that changes square x, right? But I could also go ahead and make the y location of the x a parameter in this function, call it y, and diam square. And so I will declare these as parameters. Okay, and when I hit play, again, the square disappears because if I go up and look within function draw, I haven't passed the function arguments, and it's looking for arguments to receive. So I might say that I want this to be 75. Oops. And we'll go back to 100. There's square 1. And here we go. I could put this to 300. And let's do another 100. And so there you go. You've got functions which have parameters assigned to them, and an example where in which those functions are being called and arguments are being passed to the function, which then end up allowing you to be able to reuse that function in different ways. Okay, so this is the last part of functions that I wanted to at least introduce for this week. What we have is this idea of return, right? The idea that a function can return a value. And so in this week, we're not actually going to be using return just yet. There aren't necessarily direct applications in this exact assignment that we have for return, but it's worth mentioning nonetheless. And for those of you who are more experienced with programming, you may find a way to work this into your assignment, but it's something that we're just going to cover for the sake of being comprehensive. But don't worry if you don't actually manage to find a way to incorporate this into your assignment coming up. So in addition to functions being a chunk of code that allow you to make your code more modular as well as reusable, functions, when they operate, can actually return a result, can run that function, and the function can actually create a number or a value that gets returned back to you. And so this code is directly taken from the reference from P5.js. And what it does is, you'll see in the code itself, it actually says that it returns the number 16. So at the very top of the code here, I have declared a constant, and that constant is result. It equals to this, calculate square of. And then in function setup, what we have is a create canvas and the console log, which is the result, right? And then there's function draw, which doesn't have anything in it. And then calculate square. So anyway, what we have is constant result equals calculate square. And that's it. That's a function that's defined down further below in the code. And in the comments, it says that this returns 16. We have function setup, and which then calls create canvas and console log, which is the result, right? And function draw, which has nothing actually in it at all. But what we have is, after that, this calculate square function that I mentioned before. Calculate square x, right? And it returns x times x. So basically what ends up happening is the result, by saying return x times x, the result that gets stored is the value of x times x, which, if we look at this function up here, is 4. So 4 times 4 equals 16. So let's go ahead and run the code. There's nothing that actually shows up here in the canvas, but you'll notice in the console what we see is the number 16. So the result is basically, result is printed into the console window. All right, that was covering the basics of functions in code. How you declare your functions, how you call functions, how you set parameters for functions and pass arguments to functions, as well as very briefly how return works. Hopefully that will help you get started in the process of utilizing functions, especially your own user-defined functions, for this week's assignment and for the weeks following.